Is there anyone have difficulty to hear me? Hello.
I can hear you, Doctor.
Okay, good. Okay. Okay. This is all about the final exam. So we have 5 layers. The questions will come from different 5 layers. So the first layer is the introduction and the network layer. You can see here we have introduction, data forwarding, IP version 6, and BGP. So total marks from this part is 20 marks. Time given is 30 minutes. And here we have data link, we have Ethernet link aggregation. So all of this we already covered. And Ethernet link aggregation and VLAN routing we already covered. So the second part also is 20 minutes. Sorry, 20 marks, and the time given is 30 minutes. Then here, the third part is the data link. We are going to cover the STP, RSTP, and PPP over Ethernet. So it's altogether 20 marks. Time given is 30 minutes. And after that, we have the transport and security. So we will bring some questions about maybe about IPsec or AAA or ACL, depends on the time later we will decide. And the second part will be about TCP and UDP. So for this part, guys, it's not easy. Sorry, it's very easy, especially the TCP and UDP. You have actually nothing to do with it, because here, as you can see, this level is C1. C1 means only knowledge, like simple questions like define, list, something like that. So don't worry about this part. Only this part is going to be questions that's related to configurations. So for configurations, you have to focus on this 2 parts, the data link and the algorithms under it. So link aggregation, virtual LAN routing, STP, RSTP, PPP over Ethernet, and so on. So all of this will be configuration. For the first and fourth, fifth will be C1 and C2, means knowledge and understanding, like list, define, differentiate, something like that. Okay, so for the fifth part is all about NAT, DHCP, FTP, SNMP, and all of this are going to be, as I mentioned, C2 and C1. Okay, that's all about the final exam. As I mentioned, OSPF is excluded. It's not covered in this exam. So no need to give it too much time. So please try to focus on this part. And the questions will be 5 questions. Time will be 2 hours. Full mark will be 80 marks. And that's all. That's all about it. Okay, guys. Inshallah, I'm going now to start the class about the spanning tree protocol. Okay, spanning tree protocol is a switching protocol. Switching protocol. So let me close this. Okay, the objective of our class today is the STP. Guys, I'm thinking if you have any difficulty in our labs that we have taken that I have recorded online for you. If you have any difficulty with the simulator or something like that, please let me know now. So I will open it for you. If you have any problem, you can talk now. Just open your mic and talk. Any problem with the assignment, with the labs, with anything?
I have a question.
Yes.
For the connection between the switch, does it have to be GE or can it be only Ethernet?
You mean who is talking now?
Fatin Amira.
You already asked me these questions on WhatsApp, am I right? Or,
It was me, not Fatih Amira.
because I confused. Yeah, it's similar question. Okay, anyone, no problem. Let me take this. I don't know what's this remarks here. Ultrablast on campus offline. Oh, this was yesterday. Okay, no problem. So, okay, this is the assignment. Am I right? So, which one you are asking about? This links or what links?
Between switch 1 and the 3 switches.
It can be anything you want. It depends on what you want to use. Ethernet, gigabit Ethernet are the same. Only the speed is different.
Then can I ask how can we change in the ENSP? Because when I click on it, the only one available is GE001 until 2.
Yeah, because it depends on the switch you want to use. If, for example, if let us open this. Okay, so if you go to switches here, you have two models of switches, S370 and S577. It's up to you which one you want to use. This one has limited parts. Okay, I will take one from here and one from the this one. This one is S3700, and this one is S5700. Okay, let us start them. And we will see here how many parts do we have on the switch S3700. We have only 2 GE because GE is more expensive than Ethernet. That's why this device is cheaper than the S5700. But if you go to S500, everything here is a GE. Okay, everything is gigabit Ethernet. That's why this device is much expensive or more expensive than the S3700. So it's up to you. If you want to use this, is okay. If you want to use this, is okay. If you want to use the S377, that means you have only 2 GE. Maybe you use them or you exclude them totally from the configuration. Maybe you use only Ethernet. It's up to you. No problem for me. I did not mention in the example. I intended to not mention because I know some of you can run only the 3700 and the 5700 is not working in your simulation. That's why I make it open. So you can decide whatever you want to do. Okay, any other question? If anything not clear, you ask me. You ask me now. Try to utilize your this opportunity. Okay, no more questions. So I expect today you are finishing this scenario and submitting the assignment fully, inshallah. No answer.
Okay, doctor.
Okay, everything is clear. So may I ask some questions? If anyone can tell me what type of port should be used here, here, and here?
Port link type access.
And this? This and this also?
Port link type access.
The same.
So all of this are access.
Yes.
Sorry for the writing. Is not easy because I don't have the pen. I am using my finger to write. Okay, all of this are access. What's about the other things like this?
Trunk.
Trunk. Wait. This is
Trunk link. Trunk.
Trunk,
Yes.
trunk ports. This is trunk ports. So on the trunk ports, if you use trunk, you have to allow pass. Is it? You have to allow some virtual LANs to travel this trunks. Am I right? So okay, regarding the allow pass for this link, what virtual LANs we have to pass? We have to allow. What virtual LAN? All. Okay, all. That's correct. So what's about this?
All as well.
All as well. Why?
Because it is the same virtual LAN.
Yeah, you want to allow here all virtual LANs, is it?
yes.
Why?
So that all VLAN can communicate.
So do we need all virtual LANs to use this switch to reach virtual LAN 2?
Yes.
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 So if we allow, that means the traffic from this device can travel here, and traffic from this device can travel here. Traffic from this device also can travel here. So here we will allow a lot of traffic, while we have only here virtual LAN 2. Am I right? So virtual LAN 3 and virtual LAN 4 are not going to be accessing this device. So why we should allow them traverse this link here? It's not required, am I right?
Yes.
Yeah, because even if they reach here, then data will be dropped, will be discarded at this switch. Any data from virtual LAN 4 or virtual LAN 3 will be discarded here. And also for here we should allow only virtual LAN 3 for this link. Okay, so for this link, we should allow only virtual LAN 2, and for this link, we should allow only virtual LAN 3, because in the scenario we have only this here. But if let's say we have another PC here, which is VLAN 4. So what we will have to do in this case, we have to allow 2 and 4. But if we have another one from virtual LAN 3, we have also to allow virtual LAN 3. It depends on our need. Okay? Yeah, it depends on our need. For this link is dealing with all of this. Dealing with all of this, am I right? Or not?
Yes.
Yes.
What's about virtual LAN 4? Is there anyone else belongs to virtual LAN 4?
No.
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 So even for virtual LAN 4 here is not matter to allow or not allow. So here we can allow only 2 and 3. Why? Because this VC have nowhere to communicate with any other PC, because all of the other PCs belongs to other virtual LANs. But if we have this scenario here, if we have virtual LAN 4, then here we have to allow virtual LAN 4. Clear?
Yeah.
Is that clear?
Yes.
Yeah. Okay.
Yes.
Do you have you done the configuration yet?
Yes.
So
Yes, the
Yes.
basic.
everything works
The
fine or
basic.
not?
We are just not done regarding the part that you have explained earlier.
So it seems that you work together, am I right?
Some of them, but
You discuss together. Okay,
yes.
that's fine. That's very good. I hope if you can communicate with each other, you discuss, you work together, you try to solve your problems. Yeah, that would be very good. For me, as I said before, I'm ready to answer your question anytime. Just WhatsApp me or send me an email. I'm ready to answer anytime. And inshallah, I will try to do my best to help you. And also, inshallah, for your batch, I'm going to arrange for the 1 week course after this semester. So we hope that if the government open after this month, maybe the 1st of July, they will open for gathering or something like this. If they open, then we will arrange for the course. So don't worry, inshallah. I will give you everything to be ready for the HCNA.
Doctor, someone asked, can we use hybrid?
Yes, yes, sure. If you want to use hybrid, you can. Oh, this one, Nur Iqbal. Nur Iqbal, if you use the mic is better for me because I don't read the chat all the time. For the hybrid, if we want to use the hybrid here, then we have to configure it properly. We have to configure it properly. We can choose what scenario we want to use. So hybrid can support, if let's say we have this device here, the BC number 5, which belongs to virtual LAN number 4. If let's say we want virtual LAN number 4 to be a member in virtual LAN number 3 and also a member in virtual LAN number 2. So in that case, we have to use hybrid because hybrid can support this feature. But the access and trunk, it doesn't allow. So it depends on our needs. Okay, here the assignment, the lab assignment is 10%. I make this assignment to help you because some of you have achieved, I don't want to say bad, but it's really bad. Some of you are really bad. The marks are even below 10, some of you. So I hope that I can help you. I want you to achieve good marks and so on, but I have nothing to do unless this choice. That's why I give you the assignment. I want you to give it time to try to answer it properly to get good marks. This one is 10%, so it's the half of the test. Okay. Also here you have to configure virtual LAN in all switches based on the description here. So all switches here have to be configured. As we mentioned, we have to configure the ports here to be access ports for the distribution ports that's connected to PCs. And for the other ports that's connected to the main switch here must be trunk. Or maybe if you want to use hybrid, you can configure them as hybrid, all of them. but everyone you have to configure properly. So for this, links have to be untagged. So if you want to use this hybrid, so hybrid must be untagged here, and here everything must be tagged. Okay, so that's all about it. For the hybrid, you have to know how to allow the traffic from different virtual LANs. Everything is explained in the slides. Also, you have to configure VLAN routing. So VLAN routing must be configured at this level. So if we want to configure, okay, now we will see the requirements. If we need to do routing here at this switch, if we want to do routing between virtual LAN number 4 and virtual LAN number 3 and virtual LAN number 2, then all traffic must be allowed at these links. So it depends on the requirements of the scenario. So if the requirement is only to do virtual LAN, then the traffic here is not needed to be allowed from all virtual LANs. But because the second question requires virtual LAN routing, that means we need to allow virtual LAN number 4 to communicate with virtual LAN number 3, and also virtual LAN 4 to communicate with virtual LAN 2 and 3 from other switches. So in this case, all networks or virtual LANs must be allowed. Understand? Is it clear?
Yes,
Yes.
but
Yeah.
Doctor, does the VLAN 4 need to communicate with VLAN 2 at switch 4?
Yeah, based on the question number 2, based on the requirement of question number 2, we need to allow virtual LAN 4 to be able to communicate with virtual LAN 3 and 2. That means we need to allow traffic from virtual LAN 4 to travel here. We need to allow it to travel here. Also from virtual LAN 3 to virtual LAN 2, for example, or from virtual LAN 3 to 4 to 2 from here. So every virtual LAN must be allowed. So here we need to use allow pass virtual LAN all. Okay.
Okay.
Yeah. So everything, the configuration are always, there is no standard configuration. The standard configuration or the good configuration is the one that fulfill the requirements of the user or fulfill the requirements of the organization. Okay, so everyone can configure in different way, but the only thing that we have to always guarantee the requirements of the organization and users. Okay, so we don't want to waste more time. If you don't have questions, here, make sure you run save command after you finish, before you close your simulator, you have to run the save command on all switches. For PCs, you don't have to run save command, only switches and routers. Then your topology must be saved. Also, you have to click on the save button here in the simulator. And also even after you click the save and you find the place to save your scenario, when you close the simulator, you will receive a message that will tell you, do you want to save or not? You still need to press yes. Okay. And for the ZIB file, don't use password. Submit or upload your ZIB file to Butrablast. Then the size of your ZIB file must be less than 20 megabyte. This one is the limitation of the Butrablast. So the file is supposed to be very small. So 20 megabyte is more than enough, inshallah. Submission must be before 11 p.m. of today. Okay, inshallah.
Sorry, Doctor.
Yes.
Sorry, but can you extend the due date for another day, maybe? Because yesterday we have tests.
So until when you want me to extend?
Maybe Saturday.
Maybe Saturday morning
until
or
tomorrow
evening. Yes.
Okay, I can, but you have to know something, because the system is going to close on 31st. So if you did not submit before the system close, then you will get 0. You have to understand this. I cannot do that. I cannot change I cannot ask them to open for me the system, because they are not going to open. Yeah. For this, I can change it to 27. Okay, I'll modify it now.
Thank you, Doctor.
Yeah, that's fine, no problem. All of the thing that I want to do is to help you. Okay, this one is 28, because I also need time to evaluate the things, to test them, is it working or not. So it will take time from me. I need at least 1 day to check all of your assignments, because you are 23 students. That means 23 file that I have to open and run, test and evaluate. So it will take time. That's why I cannot, I will give for myself 29th and 30 to finish, then key in the marks into the system. So for the, where's the submission setting? I don't know where's the things that I have to modify here. This one is very complicated, actually, this system. I don't know where to find it.
It's above, Doctor.
This one, I think, all is it?
The due date.
Due date is here, yeah. 27th, allow submission from, that's all, is it?
Yeah. Regarding the submission for all marks in SMP, right, Doctor? That it will be closed on 30?
Yes.
Because I've checked the SMP notification, and it said that it will be extended to 23rd of August. But I'm not sure about.
Yeah, they said this at the beginning, but suddenly they give us a very short deadline last time to key in the test one. Suddenly, like this, yeah, and that deadline is I think is not going to be working.
So for our mini project, the submission of the marks can be still submitted?
Yeah, because your project is a continuous evaluation until the last week. But for test one, because this one, this assignment is under the test one, I have to key in before week 7. That's why.
Okay.
Yeah.
Thank you, Doctor.
Yeah, no problem. If you forget about it, I can explain to you more if you want to understand this, because it's my duty to explain to you. Okay, here. Examination, where is it? Here. Okay, here you see, we have 2 types of assessment, week 1 to 7, week 8 to 12. So week 1 to 7 includes test 1. And now test 1 is not defined, it's still 20%. So that's why the modification will be allowed until the 31st. So in order to break this test into 2 tests, I have to modify the percentage. I have to make it before the 31st. You understand what I mean?
Yes, doctor.
Okay. For the other things here, we have mini project, lab, oral. This will be open until week 12. Supposed to be open until week 12. And not only week 12, actually they give extra because maybe we do some activities at the last class, then the lecturer have to have time to key in the system. So they can give 2 or 3 weeks after that for this part. But for the first one, we have to make it quickly. Otherwise, we will lose the opportunity. Okay?
Okay, doctor. Thank you for the explanation.
Yeah, no problem. Okay, anything else? If you want to ask about anything, even from the first day, the topics of first class or something like that, I'm ready to answer. So please take your time. If you want to ask about anything, please, guys.
Doctor, I have a question.
Yes.
Do we have study week?
Yes, you have study week. You have a study week. Yes. Let me see the calendar. I think this one is the latest calendar. Okay. So here from 10 to 17 March, we already have 5 weeks. Then from 18 March until 14 April, this one is holiday, I think, special holiday, is it? And after that, this one is special holiday. What is this?
Movement control order.
No, this one, I don't know. What is this?
Movement control order, doctor.
Movement, yeah.
Okay, then after that, we return back to classes on 27. So we have 2 weeks until the 24th of May. 2 weeks. Is it 2 weeks? Okay, no problem. This one is until 24 May. Then after that, we had the semester break until the 31st of May. Then after that, Kuliya from 1st June until 19 July. So we still have about 24 days or 25 days to complete other classes, other topics. Then we have the reading break from 20 July until 26 July, 1 week. After that, the final exam, you can see from 27 to 9 August. And after that, we have the holiday until 18 October. Okay, clear?
Yes, doctor.
Thank you.
Thank you, doctor.
Yeah, no problem. Okay, so I return back to our class.
Yeah.
Okay. Okay, our topic of today, as I mentioned, is spanning tree protocol with what they call it STP. STP. So this is one of the famous switching protocol used everywhere. Used everywhere in most of the devices based on many vendors. So Huawei, Cisco, Juniper, many brands, they rely on the spanning tree protocol by default. Why spanning tree protocol? Because spanning tree protocol is very smart and also has low traffic overhead, and also can detect any topology changes quickly. That's why they have been used widely. Objective of our class of today is to be able to describe the issues faced when using multi-switched network. So actually the need to use switching protocol is that when network have multiple switches, so switches by default is able to do broadcasting in many scenarios, in many cases. So that's why we have to rely on some protocols. Otherwise, our life will be very miserable to configure everything manually. Okay. The
Yes,
second thing is to explain the loop prevention process of the spanning tree protocol. Spanning tree protocol will cause some issues. One of them is the loop prevention, the switching loop. So we have to know how to prevent that loops. And after that, we will know how to configure parameters for managing the STP network design. Okay. Let us go and start with some things, some ideas, some principles actually of switching. Layer 2, the first thing is the layer 2 redundancy. Redundancy means copy of the same thing, or maybe backup of one link or something like that. So when we have multiple instances for the same thing, they call it redundancy. If you take the subject of database last time, you already take the subject with me. Redundancy in database is not a good thing, am I right? But in the network is a good thing. Why redundancy is a good thing? Because it can increase the reliability of the network, and also it will increase the stability. Why it will increase the stability? If let's say, for example, here, if we have this link have two physical links between switch A and switch B. So we can use this as an aggregate link, and also we can use it in the backup mode. So if let's say one link is lost, then the other link can take over. So connectivity will be always there unless we lost these two links at the same time. And this one is not an easy scenario to happen. But if let's say here, we have only one link between these two switches, in that case, we may lose the connectivity between some parts of our network suddenly if this link failed. Okay, that's why redundancy is a good thing. Redundancy in a switching network minimizes connection failure, but generates potential switching loops. So it has advantage and it causes some problem. So the advantage is to increase the reliability on the network. It will increase the availability, the connectivity, and everything is good, but it will cause some switching loops. Switching loops happen when one packet, the same packet, start looping like this, start looping between or along the same path for many times. This one is considered switching loop. So I will explain how it can happen. If let's say this switch is connected to one PC here, PC, and this PC wants to communicate to other PC here, and this PC doesn't know the exact MAC address of the other PC. So in this case, a broadcast message will be sent from here. Then the broadcast message will be sent here and here. And after this switch received the broadcast message, we'll send it here and here. Am I right? And also in this switch, it will receive 3 copies of the same message. 3 copies, 1 copy from here, 1 copy from here, 1 copy from here. then every copy need to be broadcast based on all available links. So it will become like salad, not networking. It will become like no one knows what's going on. So this even this packet, when we send it here, and if let's say we consider only this link, the packet will be broadcast here, then the same packet will be broadcast here, and also here. It will return back to the same switch, then the same switch will broadcast it back here and to the other side. Then this switch again will broadcast here, and it will start looping, and the life will become miserable. The network will become very slow, and it may reach the network collapse situation. So that's why network looping is very bad thing, and we have to prevent them from happening. Okay, as I mentioned, switching loops can happen when we have redundancy. Redundancy can be like this. So these two links are redundant links between the same switches. So between switch A and switch B. But also we can have redundancy like this and this. Okay? Why? Because this one, okay, I would try to use different colors. So if let's say this switch want to access this network, this switch here, it will has two redundant links. This is one link, and this is the other link. This is two, and the third one is here. So here we have three redundant links. So if let's say this one failed, then the other one here will be used. Even if we want to reach this switch, we can reach it this way, from switch 1 to switch B. So in this scenario, we have a lot of redundant links. Also from switch D, we have this and that. Also from switch C, we have two redundant here. Okay, so that's why redundancy here is implemented widely. So loops will become very common thing that will happen in this network, and it will distort the network performance. Okay, here there are a lot of comments. I'm not going to read them because I already explained to you how it happens and why it happens. The other thing we have, after we have this redundancy actually is our target. When we talk about the switching networks, in our switching networks, we want to have redundancy in our network based on the layer 2. Why we need to have the redundancy? Because we need to improve the connectivity. We need to increase the reliability on the network. We need all the time devices can communicate together with each other, and we want to minimize the connection failure. So redundancy is a target, but redundancy will cause one problem, which is the switching loop. And because of the switching loop, we will have broadcast storm. We will have broadcast storm. Actually, the broadcast storm is the same thing that I was explaining in the previous slide. When the packet is broadcast, for example, from here, from BCA to switch B, then switch B will send here and here, then this switch will send here and here, and the packet that's received from here to here, it also will be broadcast back to switch A, then to switch B, then after that to switch C, and also another thing that the other way. So here we will have like storm this way and another storm in the other way. So this will be called broadcast storms. So this can happen, this worst scenario can happen when we have like this simple scenario with 3 switches. So what if we have a network of 10 or 20 switches with redundancy? the scenario will become more worse than this. So we may lose the connectivity at a certain point. So that if we lost the connectivity at a certain point, they will call it network collapse. Okay. So to avoid this, we have to understand many things to take them in our account later. So switching loops allow for broadcast stop. So this is the main problem. This is the main problem. And this problem will cause to what they call it broadcast storms. So switching loops allow for broadcast storms to occur and duplication of frames to be received by end stations. So because of this loop and the other loop, many copies of the same packet will arrive here. Many copies from the same packet. Okay, so easily we can check if we want to check either we have what they call it switching loop in our network or not. We can easily ping from host A to host B. So our ping will send by default 3 or 4 requests. So if the 3 or 4 requests are received at the other side, then replies, if replies comes to host A are more than 3 or 4, that means we have already switching loop and broadcast storm. Because this host, if let's say we ping from host A to host B, the packets will be sent from here, for example, 4, then they are going to be duplicated here because of the storm. So instead of 4, the host B may receive like 100 or 200 packets of the same instance, of the same packet. So the replies could be 400 or 300 or 100 or whatever. Then the responses will come back to host A more than the requests sent originally from host A. So that's using this way we can detect either we have switching loops in our network or not. So easily we can detect that, and later I will explain to you using the simulator. Okay, the other thing that we will have, because as I mentioned here, the switching loop is the main issue, and this switching loop will cause the broadcast storm and also will cause something else called MAC instability. MAC instability. Okay, let us understand this scenario, how the MAC instability happen. So if let's say we send this one packet from host A, one packet from host A to reach the host B. So this packet will carry some information. Then this switch will update its own switching table. So because the packet will carry the source MAC address of host A, am I right? So MAC address, this MAC address will be linked to the interface, this one, G003. That means this switch will understand that this MAC address is connected through this interface. But after the switching loop happen, because this one is a broadcast at the beginning, this packet will be based on broadcast, then the packet will be sent here and here, 2 copies in the network. Now, then this copy will return back here, and this copy will come back here. Then the copy reaches here, will come back to switch B. So this packet originally came from here, from G003, then copied, sent here to switch C, back to switch A, then to switch B. So switch B now will receive a packet from the same MAC address, but over the G002 interface. So that's why this will be cancelled. This entry will be cancelled and the switching table will be updated. So the same MAC address of the original packet is here, the same MAC address, but here it will be told to the switch that this MAC address is connected behind this interface. So if any packet or any request comes to switch B to this MAC address, it will be forwarded wrongly to the opposite way. Instead of passing it directly to the host A, it will be taken to the other direction. So this will disturb the what they call it, the performance of the network, and this is called MAC instability. Okay, guys, here I will stop. Do you have any question in this regard, or it's clear? Please let me know now.
Yes,
Is it clear or not? Clear, is it? Anyone feel like this one is not clear?
Clear, Doctor.
Clear.
Clear.
Okay, good. Good. If you feel like you cannot understand what I explained, please let me know now. I can repeat in different way. So this is all about the MAC instability. The other thing here, we have something here in this slide is to resolve the layer 2 redundancy issue. So here, before we start here, we said redundancy is our target, am I right? We need to increase redundancy. But here, the solution to solve the redundancy issue is to stop some redundancy links, some redundant links. So as you can see here, this redundant link is going to be disabled. So why we need to disable this? Only to prevent loops. So if we disable this, then any packet, any broadcast coming from here, it has only one way. And also any broadcast coming from here, it will have only a one way. There will be no copies, extra copies from the same packet. Even though the packet comes from host A to switch B, it will be copied. One will be sent here and one will be sent here, but this one will be discarded when it reaches here for this switch. Okay? So this is one of the solutions. So sorry. Yeah? So loops are eliminated by restricting traffic flow over redundant paths. So we will put some restrictions here over the redundant path. So this one can be done actually using the STP configuration. So this link here is going to be enabled as a backup link. So in case of failure here, this one is going to be automatically enabled. Okay, so this is the features that we have in the STP. So the first solution to solve the problem of switching loops or broadcast storm is the limitation or limiting the flow traffic over redundant paths. Okay. The other thing here, let me clear. So the other thing here in this topology, in this slide here, is to show you the spanning tree protocol and how it works. So spanning tree protocol actually is based on something called root bridge. So root bridge will be the top switch in the topology. And all of the other switches connected to the network will become non-root switches, non-root switches. So an inverted tree architecture is created as a result of STP. Normally, any normal tree is like this. We will have the root here, then the branches like that. Am I right? But this way, the root is at the top and the branches are going towards the downside. Okay, that's why they call it inverted tree architecture. Inverted tree architecture. So here the top switch is going to be the root. Okay, so here we have, we can see this link here. This link is a redundant link which is used or deactivated. And this is going to be used in case of any failure. So if let's say this one failed, so this network will be disconnected. Am I right? Are you with me? Yeah. If this one failed, and while this link is deactivated, so this part will be disconnected. So if the failure happened while we implement the STP, this link is going to be activated automatically. So this part of the network will be connected through the redundant link. So we will still have connectivity to all parts of our network. Okay, is that clear?
Yes.
Yes.
Yeah.
Okay. Okay, let us check here if we have any important information here. So here we have this comments: the removal of any potential for loops serves as the primary goal of spanning tree, for which an inverted tree type architecture is formed. At the base of this logical tree is the root bridge switch. This one is the base here. The root bridge represented the logical center, but not necessarily the physical center. Okay, so this bridge here, the root bridge, is the logical center, but it's not necessarily to be the physical center. It may be physically is not the center. Okay, so I will give you some examples later to understand what I mean. Let us read and finish this comment to make sure that we did not miss anything. The designated root bridge, it's called DR, designated root, is capable of changing dynamically with the network topology, as in the event where the existing root bridge fails to continue to operate as the root bridge. So from here, we will understand that this root bridge can be changed anytime. So if let's say this switch has failure, if this switch has failure, then other switches will take over and will become the root bridge. So the center of network may change at any point of time, depends on the topology changes in our network. Okay, non-root bridges are considered to be downstream. So all of these switches are considered as the downstream switches, downstream from the root bridge. And communication to non-root bridges flows from the root bridge towards the non-root bridges. So here, what they want to mention is that all switches other than the root is considered downstream switches. And also any flow from starting from the root bridge towards the other switches, it's called downstream flows. Downstream flows. And flows from the downstream switches to the root is considered upstream flow. Okay, so flows from this direction, it's called downstream, and this direction is called upstream. Only a single root bridge can be existing in a converged STP capable network at any one time. So it's the same in any slice of time, we will have only one root bridge. Only one root bridge. Okay. Bridge ID. We have something called bridge ID. Before this, I'm going to explain to you. I'm going to explain here. Okay. Here, if let's say we have one switch here, one switch there, and one switch here, and also another switch here, then also other switch here. So maybe we have links like this. Okay. So this one is the physical topology. So maybe this is a building like this. This is one office here and another office here, and maybe another office here at the middle, and other office here, and also other office here. So geographically or physically, the center of network is this, am I right? This one is the center of the network, the physical center of the network. But sometimes we configure our switches to always select this switch as the center, as the root bridge. Okay? So in this case, maybe we want to select this switch as the root switch, maybe because this switch is the one that's connected to the router, connected to the cloud, to the internet, or something like this. Then we want to use this switch as the logical center of the network. So in this case, I'm going to undo some things from here to make it clear. Okay, so if let's say we want to use this as the logical center, so here this link is going to be active, and this link is also going to be active. This link is going to be active because this is the direct links from non-root switches to the designated router. Okay, what's about this one? This one should have only one link, one redundant link. So not one redundant, one active link at the time. So maybe it will select this link, then this link will become backup links. Okay, so based on the new selection of the DR and then the activation of the main links here, our network now will become like this. So if let's say this one is switch number 1, switch number 2, switch number 3, switch number 4, and number 5, then we can redraw our spanning tree as this. This is number 1. Then after that, it's connected to number 2, number 3, number 4, and number 4 is connected to number 5. So this is our, oh, sorry. This is our spanning tree used by the STP protocol. Okay. Okay. So what if we changed something in our configuration that makes this one, switch number 3, to be selected as the DR. So this one is no more DR, and this switch number 3 will become the DR. So in this case, I'm going to use different color here to make it clear. So in this case, the switch number 3 will become the DR. So the active links will become this one, and this one, and this one. So all of this will become what they call it, backup links. So now our spanning tree, it will become like this: 3 connected to switch number 1, connected directly to switch number 2, connected directly to switch number 4, connected directly to switch number 5. So you can see here now, with the same physical topology, we may have different spanning tree. Depends on the configuration that we have done for our switches, and also depends on the election that happens among the STP enabled switches, because the switches are going to elect the DR and the BDR later. So the DR is going to be selected based on some configuration. And this configuration, all of them can be configured manually by us, by the system, or by the network administrator. So we can control everything. We can enforce one switch to be always the DR, and we can mention based on the configuration which switch is going to be selected always as a backup DR, sorry, and the spanning tree protocol will be formed based on our configuration. Okay, until here, is everything clear? Guys?
Yeah.
Yes, doctor.
Clear. Okay, that's good. Anyone has a question? No questions?
No, doctor.
Okay. Oh, it seems that I'm a good teacher. Do you think that?
Yeah, very good, doctor.
Okay, alhamdulillah. Okay. Yeah. Now, let us go now and understand how we are going to tell the switches some information to be used for the DR election. So DR election actually is based on many things. One of these things is the bridge ID. One of these things is the bridge ID. So here, the bridge ID, let us read the comments here. So bridge ID is used to elect the root bridge. So root bridge is, the election of the root bridge is going to be done based on the bridge ID, So the bridge priority can be manipulated to force root selection. So we can give the bridge IDs to all switches, and we can give the best bridge ID for a certain switch to make it always elected as the DR. Okay, so let us read now the information here, the comments that we have below the slide. So discovery of the root bridge for an STP network is a primary task performed in order to form the spanning tree. So the first thing they have to do, I mean the switches they have to do, is to discover the root bridge. Okay, so here the STP protocol operates on the basis of election. So they have to elect the DR, through which the rule of all switches is determined. So a bridge ID is defined as the means by which the root bridge is discovered. So the root bridge is going to be the key to discover the root bridge. That comprises of two parts, the first being 16-bit bridge priority, and the second is 48-bit MAC address. So here, from this sentence here, we will understand that there is something called bridge ID, and the bridge ID is a combination of two parts. So the first part is 16-bit, and the second part is 48. Okay. So altogether is, you know how much is 64 bits. 64 bits. Okay. So as you can see here in the slide, you can find the first part of the bridge ID is includes the 4096. 4096 is the, what they call it, the bridge priority. The bridge priority. Then the second part actually is the MAC address of the switch. The MAC address of the switch. So here, based on this information, the MAC address actually is a physical thing that comes from the manufacturer. So we cannot play with that. But this switch priority, we can manually configure. So the highest priority is the lowest number. So or maybe the opposite way. The lowest value for the priority is the highest priority. So if let's say we assign it for the priority of one switch number 1, that means number 1 is higher priority than number 100. And as you can see in this sample here, 4096 is higher priority than the 32768. Okay, that's why it's selected as the root bridge. So default value actually of the bridge priority is the 32768. Okay. So here, the configuration of the root priority is very crucial. Very crucial. We have to carefully assign the priority. If, for example, we don't know or we don't want to mention one switch to be the logical center of our spanning tree, then in that case, we shouldn't play with the priority, and we make the priority equal to each other. Then switches will rely on the MAC address. So it will be, dynamically chosen without our knowledge. So the best way is to know where is your logical center, where is your physical center, also to avoid bottlenecks and to make network working in a good situation. Okay. The device that's said to contain the highest priority, smallest bridge ID, is elected as the root bridge for the network. So the root bridge will be elected with the smallest bridge ID. Smallest bridge ID is the highest priority. Then the bridge ID comprises comparison takes into account initially the bridge priority, and where this priority value is unable to uniquely identify a root bridge, the MAC address is used as a tie breaker. What does it mean? This means if we kept the priority of all switches the same, so if let's say we did not change the priority for all switches, and they by default will have the value 32768, then the MAC address actually is going to be used to differentiate or to find the highest priority of the switches. And the switch with the highest priority is going to be elected as the DR. So the bridge ID can be manipulated through alteration to the bridge priority as a means of enabling a given switch to be elected as the root bridge, often in support of an optimized network design. So mostly we need to play with the priority of the switches, and we need to decide what switch is going to play the role of the designated switch, designated root bridge. So for that reason, we have to play with the priority. We have to change them manually and to decide which one is going to be the root bridge. That's all about it. So here, bridge protocol data unit. In this slide, we have something called bridge protocol data unit, and this one is shortened as BPDU. Okay, so this is going to be used a lot in this topic. So in order to do the election to discover the root bridge of the switches, we have to understand something called BPDU. So the spanning tree topology relies on the communication of specific information to determine the role and status of each switch in the network. A bridge protocol data unit, BPDU, facilitates communication within a spanning tree network. Two forms of BPDU are used within STP. A configuration BPDU is initially created by the root and propagated downstream to ensure all non-root bridges remain aware of the status of the spanning tree topology. Okay, so as they mentioned here, the BPDU has two types. The first type is the configuration BPDU. Configuration BPDU. So configuration BPDU actually is going to be generated at the root switch. So the root switch will prepare this configuration BPDU and will send it downstream to all switches. This configuration BPDU will tell all switches about the information of the spanning tree. So all switches will have the same copy of the spanning tree generated at the root switch. Okay. So configuration BPDU is called CBPDU, and the other type is what they call it TCN. TCN is a short form of topology change notification. Topology change notification. This one. Topology change notification. So here we have the BPDU type. It can be configuration and can be TCN. So configuration BPDU is going from the bridge, going to be generated at the bridge root, and will be forwarded downstream to all other switches. But the TCN BPDU actually is, it can be generated at any switch, but it will be sent to the upstream towards the root switch. So from here, we will understand that all non-bridge switches, when they face failure in some links, they will notify the root bridge about that failure. So in order to notify the root bridge about the link failure at any point, they have to generate the TCN BPDU and send it upstream towards the root. So the root, based on the topology change notification, will modify the spanning tree. Then it will generate configuration BPDU, another configuration BPDU, and will update the downstream switches about the topology change. So all the switches will be notified about any failure or any new links attached to the network. So topology change notification can happen after a failure or after attaching a new device, maybe new switch, or maybe attaching a new link between switches or whatever. Then the switches will detect a new change in the topology. Then they have to notify the root switch. So in general, as I mentioned, there are two types of BBDU: configuration BBDU and TCN BBDU. Okay. So where we are, I think this one. The TCN BBDU is a second form of BBDU which propagates information in the upstream direction towards the root and shall be introduced in more detail as part of the topology change process. Here, in the second point here, bridge protocol data unit are not directly forwarded by switches. So if let's say BBDU is sent from the root bridge to this switch here, the switch, actually this switch is not going to forward the packet as it is, but it will modify something. It will modify something at the BBDU, then it will forward the BBDU, the new BBDU, to the downstream. So again, BBDU are not directly forwarded by switches. Instead, the information that is carried within the BBDU is often used to generate a switches on BBDU for transmission. So the original BBDU that comes from the root to this switch actually is going to be used to generate another BBDU, and the new BBDU is going to be sent to the downstream switches, and the original one is going to be discarded. A configuration BBDU carries a number of parameters. So inside the BBDU, as you can see here, in the format of the BBDU bucket, it has a lot of parameters here. So these parameters are used by a bridge to determine primarily the presence of a root bridge and ensure that the root bridge remains the bridge with the highest priority. So each LAN segment is considered to have a designated switch that is responsible for the propagation of BBDU downstream to non-designated switches. Okay, this is nothing new. So that means every network should have the root bridge, and the root bridge is responsible to send the BBDU, configuration BBDU, to the downstream switches. Then the other thing here, the last point, is that the bridge ID field is used to determine the current designated switch from which BBDU are expected to be received. The BBDU is generated and forwarded by the root bridge based on a hello timer. So hello timer actually is used by many protocols, and we have already explained before. So hello timer, if let's say we make it 10 seconds, then every 10 seconds a hello message is going to be sent, which is set to 2 seconds by default. So here the hello timer is by default set to 2 seconds. As BBDU are received by downstream switches, a new BBDU is generated with locally defined parameters and forwarded to all non-designated switches for the LAN segment. So as I explained, the original BBDU sent from the root bridge to this switch is going to be used to generate another BBDU based on the local parameters of this switch, then the new BBDU is going to be sent to the downstream, and the original BBDU actually is going to be discarded. Okay. Here, one of the parameters that we have to modify from switch to another, that's why we need to generate BBDU every time. The original BBDU have to be discarded after we generate a new one based on the local parameters. One of these local parameters in the path is the path cost. So here, root path cost is carried in the BBDU and used to determine the shortest path to the root. So here, path cost actually is representing the cost from a certain point. If let's say from this switch to this switch, let me use the notation, from this switch here to this switch, the cost is set to 20,000 here, 20,000. So based on these costs here, assigned for every port, the STP will define or will find the shortest path, or by other way, the cheapest path is considered the shortest path. Okay, because we need to reduce the cost. The cost actually here is a logical cost. So cost is going to be set based on some other parameters that we will learn later in the coming slides. So here, the root path actually is going to be attached, or to be, I mean, modified in the switch, because when the packet comes from here, the BBDU comes from the root bridge to this switch here, the BBDU cost, path cost is 0, but this switch has to modify it. It must be 20,000 plus 0. So it will be modified in the BBDU, then the new BBDU with the new path cost is going to be forwarded to the downstream switches. Okay? So root path cost is called RPC. RPC is used to measure the cost of the path to the root bridge in order to determine the spanning tree shortest path and thereby generate a loop-free topology. When the bridge is the root bridge, the root path cost is 0, because if the root bridge, if we are at the root bridge, how much is the cost to reach the root bridge itself? It's 0, because we are in the root bridge. But from other switches, we will have extra cost to be added to the RPC field. The path cost BC is a value associated with the root port, which is the port on the downstream switch that connects to the LAN segment on which a designated switch or root bridge resides. So from here, if let's say we have, sorry, I have to open the, because this thing is very important. I have to explain it carefully to allow you understand it. Okay, if let's say we have this root switch and this is the other switches here. Okay, if let's say this is the connections that we have. So this one is going to be backup. Here, every port here, here, and here, every port, they must have something called port rule. Port rule. Okay, So this part rule actually is going to be decided, depends on the connection type and depends on the direction of the connection regarding the root bridge. So if this one is the DR, designated root bridge, so designated root bridge, all ports must be designated, port, which is annotated like D. Okay, if I'm not mistaken, I'm afraid that I explain about different protocol. So we have DR and A, DR and A. Okay, so in the root bridge, all ports must be D. All ports must be D. And for the other non-root bridge switches, the port that's connected to upstream towards the DR, this one is going to be set to root port rule. So it's going to be R. So the port is pointing to the upstream side is always going to be R. And for this is pointing to the downstream. So this one is going to be D. And this one is D. And for this here, one of them is going to be D and the other one is going to be alternate. Alternate means backup. Okay, so this one and this one actually is going to be decided based on the priority of the switches. So if let's say the priority of this switch is higher than this, that means this side is going to be D and the other side is going to be A. But if the priority of this switch is higher than this, then this one is going to be D and this one is going to be A. Okay? Until now, is this clear, guys?
Doctor, why is at the root there is also called D?
Sorry?
At the top one?
Yeah.
Why is it also called ST?
You mean this one?
Ah, yes.
Actually, this one is the DR. DR is the top switch. So
okay.
Top switch, what does it mean? Top switch means all ports are connected to the downstream, are pointing to the downside. Am I right?
Oh, yes.
Yeah. So all of the ports must be D. Must be designated ports. So if you check a switch, then you find all ports are set to the D mode. That means this switch is the DR. But if you check all ports and you find some of them R, some of them D, and maybe you have one or two A's, that means this is a non-bridge route. Okay, understood?
Right.
Yeah.
Yes.
So
it's the same as the D at the below.
Yeah, it's similar. Any port that points to downstream like
okay.
this is going to be set to D. Okay,
right.
So this one, and this one is going to be set to D. And here the backup. This one, it depends on which one of this is higher priority. If let's say this one is higher priority, then we have to redraw the things like this. This one is here, and that one is below, and then another one is here like this. So this one is like this, and this one is like this. You see? So now this port is pointing to downstream. Am I right? So this one is going to be D. This one is pointing to downstream. Also, this one is D, and this one is downstream D. This one is downstream D. And this one, because this one is a backup, So this side is going to be A. And all of these ports, that points to the upstream, all of them will be R. Understood?
Yes, doctor.
Very easy,
Thank
very
you.
simple. Okay, guys, anyone have question in this regard? Hello?
No.
No, no questions. So everything is clear until now.
Yeah.
Yes, doctor.
Yes.
Okay, good. Okay, so let us go back to the slide. Okay, since you already understand what is the designated port and what is the root port and so on, then here we will see that the new, this one, we need to understand this. Where did we stop? This value is used to generate the root path cost for the switch by adding the path cost to the RPC value that is received from the designated switch in a LAN segment to define a new root path cost value. This new root path cost value is carried in the BBDU of the designated switch and is used to represent the path cost to the root. Is it this? The one that we stopped on last time? Okay, no, don't worry about it. I will explain it in another scenario. I will draw another scenario, then I will explain to you how we are going to use the costs. So here, if let's say we have this scenario like this, then here. So here, let us put the annotations. Here we have D, 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 and here one D. And this one is A. Why? Because this one is a backup. And here is R. Here is another R. This one is R. And here is another R. Okay. So at any point of this network, we have to know switches, STP switches have to know what is the cost to reach to the DR, the designated root bridge. So from this point, we need to know what is the cost to reach the DR. So that's why every root rule port, it have to have something called root bridge cost, RPC. So RPC have to be set here. If let's say we put 20 here and maybe 30 here, maybe this one is 30 and that one is 20 because this one is maybe longer than this. It depends on what scenario we want to use, or maybe the speed here is faster than the speed here. So it depends on what standard you want to use. And for here we don't assign RPC value to the ports. So this port will have 30, this port will have 20, and this one may have like 50 or something like this, and this one may have, for example, 60, like this. So if let's say the configuration BBDU is sent from here to here, the BBDU should have something always called RPC, and here the RPC at the root bridge is equal to 0. So when the RPC, when the BBDU comes from the DR towards the downstream switch, the downstream will receive it over the root port, So the cost attached or assigned to this root port actually is going to be added to the value, to the original value in the BBDU. So the new BBDU generated at this switch should carry RBC equal to 20. Then this switch should send it downstream to other switches. So when this switch receive the BBDU will carry the value of RBC equal to 20. So this switch has to add this value 50 to the original value, which is 20. So the new RBC will become 70. So from this scenario, this switch will know that the cost to the DR is 20. And at this point, this switch will know that the cost to the DR is 70. Okay, is that clear, guys?
Yes.
Okay. So that's all about it. It's very simple, but as I mentioned, it's tricky. Okay, so how we are going to use or to change or to modify the path cost? Actually, path cost can be manually changed, but it's not advised to be changed manually. It's not recommended to be changed manually. Why? Because manual change means that every time we have different connection type, or maybe different cable, or maybe different port, then we have to modify manually based on the change, based on the physical change. That's why we better enable or use one standard with all switches. So this standards actually related to the root path cost actually is 3. So we have the path cost legacy, this one, and also we have 802.1T and 802.1D. So as you can see here, in every standard, we have a certain value for every speed, So automatically, based on the port speed, the RPC is going to be assigned automatically. Okay, clear, guys? So
Yes.
for example, if we enable the standard of 802.1D, then if our connection is 10 gigabit per second, the RPC is going to be equal to 2 for that port that has the speed of 10 gigabit per second. Also, ports with the 1 gigabit per second is going to be 4. 400 megabit per second is going to be 18. For 10 megabit per second is going to be 99. For the other standard, which is the .1T, you can see the different values here is very high, big values. For the legacy, it starts from 2 until 1999. So here, I'm going to explain why we need to use one of these standards. But before that, I'm going to go through these comments to let you understand all of the needed information. Then after that, I may explain to you some scenarios. So STP supports various bad cost standards. As I mentioned in the table there are 3. The 802.1T is the default standard used by Huawei switches. So .1T is the standard used by default with Huawei devices. Okay, so without doing anything, the .1T is going to be enabled by default. Okay. What's about the 802.1D? Actually, 802.1D is the standard of the Cisco. Okay. We will come back to this later. Why? Which one is better, the standard of Huawei or the standard of Cisco? And I will explain to you why. But before that, we will read the comments below the slide here. Huawei SX7. This one means the Huawei series 7000. So 7000, as you can see here, is like this switch, S5700, not the S3700. So we talk about the 7 series. So 7 series switches support a number of alternative path cost standards that can be implemented based on enterprise requirements, such as where a multi-vendor switching network may exist. So you remember this point, okay? So if let's say we have multiple vendor switches in our network, then we have to play with this standard. Okay, so the Huawei SX7 series of switches use the 802.1T path cost standard by default, providing a stronger metric accuracy for path cost calculation. So from here, sorry, from here we understand that the 8021T is a higher accuracy compared to the others, but maybe you think that because these slides are coming from Huawei, they want to tank their standard. They will say that our standard is better than the others, but really it's not. This is the reason. It's not based on this reason. This standard, actually, the 802.1T is higher accuracy. Why? Because it has a very big gaps between all speeds. So you can see here the gap between the 10 gigabit and 1 gigabit is very tight. Here we have the gap is more than 18. It's about 18,000 here. Here we have the gap is only 18, and the minimum number here that represents the highest speed is 2 here, while here is 2,000. Here is 2 also. So what will happen? What will happen if we have something like this? If let's say we have 25 gigabit per second and 40 gigabit per second, which is a real scenario now. Now we have even networks that have speeds more than this. So now the available networks can support 160 gigabit per second. If let's say the other one is 100 gigabit per second. So now, if we use 802.1D, so what is the number that we can give here for the cost of the 25 gig? We have only one, am I right? Only one number has been left. So what's about the 40 and 100? It will be all one, because we cannot change this. We cannot change the 99, we cannot change the 18, because this one is a standard. So if we want to change, then we have to go manually and change all of the ports manually, which is not an easy task, especially if we have a big number of switches connected to our network that may involve thousands of ports. So that manual change may take days. Okay. So here for this scenario, also, we will have the same thing. We will have the same thing. So what this means? This means that the switches cannot differentiate between the speeds above the 25 gigabit per second. So they will treat all of these speeds as the same. While 100 is 4 times faster than the 25. Am I right? So this 100 is going to be treated as 25. So because of this, we may have faster link set to backup mode, while slower link is activated as a main link, which will degrade our network performance and also will waste our resources. So that's why they considered this standard and that standard as non-accurate. But for the standard of Huawei, because they have seen these issues at Cisco and at the other brands, and they try to avoid. So here in this standard, we still have 1999 values that can be used. So we still have about 2000 speeds can be considered in this standard. So 25 can be like 155, and this one can be 1000, this one can be 500. And we still have about 500 above the 100 gigabit per second speed. So based on this values, we can see that the gap is still very big between different speeds, which will make the accuracy of the standard higher than the others. Okay? Guys, is this clear or not?
Yes, Doctor.
Okay. So no question yet?
No.
No, very understood.
Okay, good.
So far, so good.
Okay, that's nice. Okay. Spanning tree port rules. Actually, the STP is a quite long topic, but as I mentioned, it is not hard. It's very easy to understood. But as I mentioned, it's tricky. It has multiple parameters, and we have to focus. Because also for the cost, we have two types of costs. The first type is the RPC, which is the route path cost. And after that, we will have the port cost. So every port can have a cost. So here, convergent spanning tree network defines that each interface be assigned a specific route, a specific port rule, as I explained before. And for the spanning tree protocol, 3 port rules of designated route and alternate are defined. So we have 3 types of port rules: D, R, and A. So D is pointing towards the downstream, and the R is pointing towards the upstream, and the A means alternate. Okay. So the designated port is associated with a route bridge or a designated bridge of LAN. I think all of this is already explained. I already explained all of this. No need to read it again. So maybe I read only this too and explain them only. So spanning tree supports designated route and alternate port rules. The route path cost, RPC, enables port rules to be determined. So what they call it, the port rule actually is determined dynamically, or decided based on the shape of the spanning tree. So if you go back to the previous scenario that I explained, that has 5 switches. That scenario that has 5 switches like this. So at the beginning, we have one shape of the spanning tree. Then after we change some configuration, then the shape of the spanning tree changed. So it depends on the shape of the spanning tree, the route bridge ports will be decided, and also the designated ports will be decided. So that's why we need to carefully know about the configuration that we want to do. So if the spanning tree shape is changed, then the port rules will be changed relevantly. Okay. So other thing, we have something called port ID. Port ID. Don't mix up things. We have bridge ID here. So bridge ID is used to find the highest priority of the switches to be selected or to be elected as the DR at the designated route bridge. Okay, here we have this port ID. Port ID actually is used to determine the port rule, Okay, so here where the route path cost is equal, if the route path cost, the RPC is equal, port identifier is used. Port identifier is used to determine the active and alternate paths to the route. Okay, so this port ID is very important when we have redundant links like this. So which one is going to be designated, and the other one, which one is going to be R, and which one is going to be A. So this one will decide what redundant link is going to be inactive and which one is going to be activated. Okay, so this scenario or selection of the active and inactive links will be done based on the RPC, of every port. RPC of these ports can be the same. Am I right? So if, let's say, the first port and the second port have the same RPC equally, then the port ID is going to be taken into account to decide which one is the higher priority. So the port ID is the number of the port in the switch. If you check any switch, here, any switch in the market, so switch front. Switch front. Okay, so here in every network switch, you will find I think we have to open images. Okay, for example, this one, you will see this port number is 1, 2, 3, 4, 5, 6, 7, 8, and so on. Depends on how many ports do you have and which one you are using. So if, let's say, you selected port number 1 and port number 2 to be redundant, to be connected to other switch for as redundant links, then if the cost of these two ports are equal, then the port number 1 is going to be considered higher priority than the port number 2. So here the port ID is going to be used. So the lowest port ID is the highest priority. Okay, is this clear, guys?
Yes.
Okay. So now you understand based on what we are going to select the alternate port rule or the route port rule. So it depends on the RPC. If the RPC is equal, then we have to check the port ID. So the the smaller port ID is the highest priority. So the highest priority is going to be selected as R, it will be active, and the lowest priority will be selected as alternate, and it will be inactive. This inactive link will be activated in the case of the failure of the other active link. So the port ID is tied to each port. So as I mentioned, each port has an ID that comes from the manufacturer and comprises of port priority and port number that that associates with the port interface. So the port priority is a value in the range of 0 to 240, the value of from 0 to 240. This one is what? Port priority. Okay, so now we are going to more details. So in this point, we are going to consider this, the numbers of the ports that comes from the manufacturer. In the second point here, we are going to more details that tell us about the priority of the port, which can be a value of 0 to 240. So this priority can be assigned manually. So assigned in increments of 16. So here the value can be 0, 16, 32, and so on until 240. So, and represented by a value of 1 to 8 by default. So the default priority assigned to all ports by default is the 1 to 8. So where both port interfaces offer an equal port priority value, the unique port number is used to determine the port rule. So what does it mean? Because we have the priority by default set to all ports, the priority set to all ports by default equal to 1 to 8. So in this case, to find the highest priority, we are going to rely on the physical numbering of the ports that comes from the manufacturer. Okay, but if we modify the priority of the ports manually, then things can be changed. Maybe we make port number 10 higher priority than port number 1. So it's up to you how to make it. So the highest port identifier, the lowest port number, represents the port assigned as the root port. So from here, we will understand that the highest priority, which has the lowest number of the port, it will be selected as a root port, with the remaining port defaulting to an alternate port rule. Okay, to understand this, I'm going to take one example. So please, all of you open your mics and participate with me. So let's say we have 2 links here, 1 link here, 2 links here, and 1 link here, 1 link here, and 1 link here. Okay, guys. Now, what I want to do is to find or to assign the port rule for every port. So if let's say this one is the DR, and this one is higher priority than this. Okay, can you tell me now, what is this port?
Where dot they?
Sorry?
Which
Port.
one?
This port at the DR.
D.
So, okay, one rule that we have to always remember that all DR ports must be set to D. Must be set to D, am I right? Why? Because the root bridge is the top level, and all ports must point to the downstream. So all of them must be D. Am I right? What's about this?
D.
D, correct. What's about this?
Also D.
Also D. What's about this?
D.
D.
D. Okay. Okay, what's about this?
That one
D.
is D.
D
D.
also, because as I mentioned,
Priority.
this one is higher priority than this. So this one is
Yes.
also D.
D.
This is if we assume that the port priority is kept as the default. Okay. So here, now all the ports that points to the downstream has the letter D. So what's about the other ports like this?
R.
This one is R. Why? Because this one is pointing to the upstream. What's about this?
Also
R.
Also R. This?
R.
This one.
Wait.
Sure R?
Is A.
Because here we have dependent. Sorry, redundant links.
Oh.
A.
A and R.
So if we assume that this one is a higher cost than this, then this one is going to be R, and this one is going to be A. Correct?
Yes.
Because the cost here is lower than the cost here. Okay? And what's about this?
Also A.
Why A?
It's a backup link.
And this?
No.
Because there is lower priority.
So what to do? What to do here? Okay, it's easy. Okay, it's very, very easy. Why very easy? Because as I mentioned here, the designated route bridge, all ports must be set to D. Am I right?
Yes.
What's about the non-route bridge? Non-route bridge must have only one port as R. Only one port as R. And the remaining ports can be D or A. Can be D or A. Clear?
Yes.
Okay, so from here, what's about this? Is it D?
No, it's not D.
Is it R? Okay,
No, it's not R.
Why it's not D?
Because the other no route
pointing.
is D.
It's pointing to the upstream, am I right?
Upstream.
Yes.
Yeah, and
Yes.
okay, why it's not R? Because we already
Because
have
only
one R.
can.
We already have one R, so the remaining must be, this one is A and this one is A. Alternative. Okay, so one of these two is going to be activated in the case of failure of the R link. Okay, understood?
Yes.
Okay, so now what's about this and this?
R and
suppose
A.
that this one is port number 1 and this one is port number 2. So which one is going to be used, is going to be set to R? Which one?
One.
The one that has higher port priority, am I right?
Port number
So
one.
we assume that all ports are still using the default port priority. So the port number is going to be used. So port 1 is going to be set to R, and this one is going to be set to A. Why not D? Because this one
Because it's
is
going upward.
pointing to the
Pointer
upstream
to
side.
upstream.
To the upstream side. Okay, to make it more clear for you, I will explain you how is or what is the possible combination of letters. So the first combination is the D and R. The second combination is the D with A. So D with D is not possible. R and R is also not possible. A and A also not possible. So you have only two options for the port assignment. So if let's say this one is D, and this one is R here, and this one is also D. So one side is D, the other side can be either A or R. Am I right? So R we already have. So by default, it's supposed to be A. 1000% supposed to be A. Okay.
Okay.
So we have always to remember this. Always. And also we have always to remember that the designated route bridge is all ports are supposed to be set to D, because all ports are pointing to the downstream. And for the non-bridge switches, we can have only one R. We can have only one R port. Okay? Is that clear?
Yes, Doctor.
Okay.
Yes.
I think it's like a fingertips, is it? Very simple.
Yeah. Yes, clear,
Yes.
Doctor.
Yeah.
Doctor,
Yes.
have you explained this in the class, because I feel like deja vu here.
You feel like what? You
Deja vu.
you feel like
I
you
feel like-
already know this before.
Yes.
No, we never explained this before.
Oh, okay.
Okay, good. Yeah, it's a good good thing, good sign. Okay, let us go. We didn't take the STP, is it, in the class? This is the first time we take this STP, spanning tree protocol. Yeah, that's why we never explained this before. Okay, so all of this now is very clear. Okay, so if you want to go through this, I already gone through this. We are going to the other slide, timers. So don't worry about the time that we consume here, because this part is very important for the STP and the RSTP. Because after we finish this, the next class is going to be the RSTP, which is the Rapid Spanning Tree Protocol. Okay, so that's why I give it enough time to be understood. Let me attach my power cord first, because the battery is going to finish. Okay, so here we go to this slide and we see the timers. So timers are actually a very common scenario to be used with the protocols. So here the max age represents the aging timer of a BBDU. So one type of timers is the max age. So this max age means that for how long the received BBU is going to be valid. So after the max age expired, that means the BBDU is already invalid. It's expired. So the switches will expect that a new BBDU should arrive. Okay? BBDU are discarded when message age exceeds max age. So if the packet, the BBDU packet is traveling from the root bridge and the maximum age is expired when the packet arrives here at this switch here. For example, if the packet, the maximum age is expired, then the packet BBDU is going to be discarded. So this switch is not going to consider that BBD. Okay, let us take this scenario here. So BBDU interval is 2 seconds. So every 2 seconds, BBDU is going to be generated and sent to the downstream switches. So here, the message age is 0, and the maximum age is 20. Here, when the packet is arrived to this switch, the message age will become 1. So the age actually represents the number of switches that the BBDU travels through. So in every switch number, the message age is going to be increased by 1. So here, the message age is 1, which is less than the maximum age of 20. So that means the BBDU is still valid, not expired. Then the packet will be considered here. So a new BBDU will be generated to use the local parameters, but this parameters will be kept. So when the BBDU is sent down to the other switch, so the other switch will increase the message age to number 2. Okay, so here it will arrive. So when the message is going to be expired? So based on this case, if the maximum age is 20, the message is going to be expired if it exceeds 20 switches. If it exceeds 20 switches. So this is the first switch will increase number 1. The second switch will increase number 2, the third, fourth, until 19, 20. So the switch number 20 in the downstream will add 1 to the message age, and the message age will become 20. So 20 is not greater than 20, still valid. So the switch number 20 can receive a valid message, but switch number 21 is not going to receive a valid message. So based on the maximum age, we can decide the size of our spanning tree. The size of our spanning tree. Okay? So if we want our spanning tree to have branches of maximum 5 switches, so in this case, our maximum age must be 5, must be set to 5. So the sixth switch is not going to be involved in the same spanning tree. So the sixth switch have to create its own spanning tree topology. Okay? Is that clear, guys?
Yes, Doctor.
Okay.
Yes,
so,
Doctor.
Clear,
okay,
Doctor.
good.
Doctor,
now,
yes.
Yes.
Can we end this class because I have to go somewhere else?
Oh, now time is 12:30. Okay, let us stop here. Let us stop here. Then I will finish this. I will record the remaining of this class, and I will upload it to the Butrablast. So later, if you have in the next Friday, if you have any questions, you can ask me. And in the next Friday, we are going to take the opportunity to discuss the STP and RSTP together. So please try to give it time to understand it. Try to summarize the things in your own way. And also don't forget to submit your assignment. So the deadline is tomorrow night. Okay. Thank you guys, and see you inshallah next class inshallah. Okay.
Thank you,
Yeah,
Doctor.
Yes.
Thank you.
Have a nice day.
Doctor.
Assalamu alaikum.
Thank you, Doctor.
Salam.
Waalaikumsalam.
Salam.